Just think about this for a second. If you look up at the sky right now, are you actually seeing the universe as it is today? Not really. You're looking into the past. The light reaching your eyes from a star right now might have started its journey millions of years ago, which means that star you're looking at might not even exist anymore. But here's where things get really weird. What if we could look so far into space that the light reaching us came from almost the very beginning of the universe? What would we see? A baby universe? Or something that shouldn't be there at all? That's exactly the kind of question the James Webb Space Telescope was built to explore. But when Webb started looking, scientists ran into something unexpected. Some of the early galaxies looked way too mature. Imagine you had a spaceship, and you could travel to any point in space. If you traveled 1 million light years away and then looked back at Earth, you wouldn't see Earth as it looks today. You'd see Earth as it was about 1 million years ago. 10 million light years away. You're looking roughly 10 million years back in time. A billion light years. You're looking a billion years into the past. So telescopes aren't just machines for seeing far away. They're basically time machines. The farther away we look, the further back in time we see. And James Webb was designed to push this idea further than ever before, to look toward a time when the universe was still incredibly young. But before we talk about what Webb found, we need to answer a much bigger question. How did we even figure out that the universe used to be much younger? About a century ago, our picture of the universe looked completely different. A lot of people imagined the cosmos as something basically static, something that was just there. Then Einstein's equations came along, and they created a problem. General relativity showed that the universe could actually be dynamic. It could expand or contract. But the idea of a changing universe was pretty strange at the time. Then astronomers started studying distant galaxies, and they noticed something interesting. The light from many of these galaxies was shifted toward the red end of the spectrum. This is called redshift. And generally speaking, the farther away a galaxy is, the more we see the effects of cosmic expansion in its light. That changed the picture completely. Galaxies aren't simply flying through some giant fixed space. Space itself is expanding. And if we could somehow rewind that cosmic expansion, the universe would become smaller, hotter, and denser. But there's a huge misunderstanding about the Big Bang. The Big Bang wasn't simply an explosion happening at one point in empty space. It's actually much stranger than that. Space itself was expanding. So if we rewind the cosmic story, it's not just that galaxies get closer together. The distances between things change too, and eventually, we arrive at a universe that was incredibly hot and dense. But here's the problem. Can we actually look all the way back to that moment? Not directly, because the early universe was basically a hot, dense fog. Light couldn't freely travel through it. Then, roughly 380,000 years after the universe began expanding, things changed. The universe cooled enough for light to travel freely, and that ancient light is still traveling through space today. We call it the cosmic microwave background, basically a ridiculously old snapshot of the universe. But that was only the beginning. Back in the 1960s, two engineers named Arno Penzias and Robert Wilson were working with a radio antenna. They weren't trying to discover the beginning of the universe. Not at all. They were just trying to get rid of a strange background noise, but no matter what they did, the noise wouldn't go away. They checked the equipment. They cleaned the antenna. They changed its direction. Nothing worked. The signal seemed to be coming from everywhere. Eventually, they realized that the annoying noise wasn't noise at all. It was one of the most important pieces of evidence from the universe's early history. The universe was basically sending us a message from its childhood. That discovery became one of the strongest pieces of evidence supporting the Big Bang model. But there was still a huge question. If the early universe was so smooth and simple, how did the first stars and galaxies actually form? After the early universe, there was a period we often call the cosmic dark ages. There were no galaxies like the ones we see today. No huge collections of stars lighting up the universe, but gravity was already working. Slowly, very slowly, gravity started pulling matter together. Huge clouds of gas collapsed, structures began forming, and eventually, the first stars switched on. If we could somehow watch that moment, we'd literally be watching the first lights in cosmic history, and that was one of the things James Webb was built to investigate. But when the data started coming in, the story got a little strange. James Webb started finding galaxies incredibly far away, so far away that their light had been traveling for billions of years, which means we're not seeing these galaxies as they look today. We're seeing them as they looked when the universe was still very young. According to many expectations, we should have seen small, chaotic galaxies still struggling to grow, but some of them looked surprisingly bright, and some appeared more developed than expected. That raised a serious question. Did the early universe build stars and galaxies much faster than we thought? Or were we simply misunderstanding what we were seeing? And that difference matters, because one strange observation doesn't automatically destroy an entire theory. Sometimes, it just means we don't have all the pieces yet, but galaxies weren't the only surprise. Webb and other observatories have also helped us study extremely bright objects in the young universe, some of which appear to be connected to rapidly growing supermassive black holes. And that creates another strange question. How can something that normally needs a lot of time to grow become so massive when the universe itself is still incredibly young? A black hole has to grow by pulling in matter, gas, stars, other material, sometimes even merging with other black holes. But the early universe simply hadn't had that much time. So how did some of these black holes grow so quickly? Did early black holes have faster growth mechanisms? Were the conditions of the young universe completely different? Or are there still parts of black hole growth that we don't fully understand? And that's where the story stops being just an astronomical discovery and becomes a real cosmological mystery. But one of the strangest parts of the story was still coming. In James Webb's images, scientists started finding mysterious objects that became known as little red dots. They're small, they're incredibly distant, and they're surprisingly strange. Scientists are still working out exactly what many of them are. Some may be compact galaxies. Some could be connected to active galactic nuclei and growing black holes. And some might involve a combination of different phenomena. And that's what makes this so interesting. We don't have every answer yet. And when a telescope gives us more questions instead of fewer, that doesn't necessarily mean it failed. Sometimes, that's exactly what a great telescope is supposed to do. Now let's get to the controversial question. Did James Webb prove that the Big Bang was wrong? No. And this is one of the most important points in the entire story. The Big Bang model isn't based on one prediction about how many galaxies should exist. It's supported by multiple lines of evidence. The expansion of the universe, the cosmic microwave background, the abundance of light elements, the large-scale structure of the universe, and many other observations. But that doesn't mean we understand every detail. Maybe our models of galaxy formation need to be updated. Maybe stars formed faster in the early universe than we expected. Maybe black holes had different growth pathways. Maybe some measurements and estimates need to be refined. And maybe there's still new physics waiting to be discovered. So perhaps James Webb didn't come to destroy the Big Bang. Maybe it came to force us to build a better version of the story. And here's something even more mind-blowing. We still don't actually know what most of the universe is made of. The ordinary matter that makes up stars, planets, and us is only a small part of the cosmos. A huge portion of the universe appears to be made up of dark matter and dark energy. But we still don't know exactly what either one really is. We know dark matter mostly through its gravitational effects, and we infer dark energy from its role in the accelerating expansion of the universe. So when we tell the story of cosmic history, we're actually telling a story where some of the biggest characters are still missing. We can see what they do, but we don't fully know what they are. But if you think the biggest mystery is, how did the first galaxies form? There's an even bigger question. What came before the first light? What came before the universe became transparent? What came before the Big Bang? And here's where things get really complicated. In some interpretations of physics, asking what happened before the Big Bang might be like asking, what's north of the North Pole? Because time itself, in our current understanding, may be connected to the very early state of the universe. But that's not the only possibility. There are different theoretical ideas: cyclic universes, cosmic bounce scenarios, inflationary models, multiverse ideas, and different attempts to connect quantum physics with the earliest moments of the cosmos. But there's an important distinction. These are theoretical possibilities. They should not be confused with established facts. And that's exactly what makes the story so exciting. We still don't know how the first chapter begins. Now, let's go back to that night sky. The same stars, the same silence, the same Milky Way from Earth. Everything looks peaceful. But behind that peaceful view, the universe is expanding. Galaxies are being born, stars are forming and dying, black holes are growing, and the light reaching your eyes tonight may have started its journey billions of years ago. We look up at the sky, and we think we're looking at space, but really, we're looking at history. And maybe the strangest part is this: the better our instruments become, the simpler the universe doesn't look. It gets stranger, and we get more questions. Maybe James Webb was never supposed to read the final page of the cosmic story. Maybe it was only supposed to show us a page we'd never been able to see before. And if that's true, then everything we know about the beginning of the universe isn't the end of the story. It's just the point where our flashlight finally reached. So maybe the real question isn't, when did the Big Bang happen? Maybe the real question is, if this was only chapter 1, where is chapter 0?